All right, guys, are there any questions over the homework assignment before we get started?
30. Wait. 28.
Okay, so we'll look at 28 first.
I'm just asking questions for myself.
You have the note sheet from yesterday?
Oh, yeah. Where's the note?
Should be that page right there. 20. So the first thing we want to do is describe the transformation. So the negative 5 is down 5. This would be 28. The plus 1 inside the parentheses would be our left and right, and it would be left 1. Now the negative 4 out front actually is two different transformations. The negative is a reflection across the x-axis, and the 4 is a vertical stretch of 4, because if it's greater than 1, it's a vertical stretch. If it's between 0 and 1, it's a vertical shrink. We know it's not horizontal, because for it to be horizontal, it would have to be inside the parentheses in front of x. Now the other part we need is the vertex, which is our h comma k. Negative 5 I agree with. 1 I halfway agree with. Because it's not positive, it is negative. Because since we have plus 1 inside, it has to come out as negative 1. Any other questions on number 28? Yes. If you want to make a correction, yes. But if you feel comfortable with it, then no. Okay, yeah. No. Okay. I was looking right at it. You're welcome. Questions on 28? That's the same thing. Same thing. Nope. The order that doesn't matter. Now 30, f of x is equal to 1/2 parentheses x minus 1 squared. Now this one, unlike the last one, only has two transformations. The x minus 1 inside the parentheses is going to be right 1. We don't have an up and down. We don't have a horizontal stretch or shrink. We don't have a reflection of the y-axis or x-axis. But the other half is the 1/2, which would be a vertical shrink of 1/2. 32? 30, yes. Yeah. Because I was trying to remember that earlier. Yeah, it is 27 through 29. Oh, crap, I did extra. Yeah. Now the vertex for this would be 1, 0. Mm-hmm.
I don't know why that one confused me when it says.
Questions on any of these here? Now we're going to look at the notes for today. Now, we worked with the vertex form of a quadratic yesterday. We've talked about those. We've looked at them. And the vertex form is this form here, or a times x minus h squared plus k, where the h and k give us the vertex. Now, one piece of information that's new is our axis of symmetry is the vertical line x equals h. It's the line that cuts the parabola in half. And what's interesting with this here is that the distance, a point on the left side of this axis of symmetry, the distance it's away from it, is going to be the same as the corresponding point on the other side. They mirror each other. It's reflected across this axis of symmetry. It's symmetrical across this line. So if I know one point on the left of it, we will also know the point on the right. And they're going to be equal distance from each other. Questions on this so far? Now, what we're going to be looking at with these equations, these quadratics, is one, we're going to find the vertex. Then we're going to find the axis of symmetry. Now, the vertex is still the point h comma k. And our general form is a times x minus h squared plus k. Now, the axis of symmetry is given to us by the equation x is equal to, or x is equal to h. Now, looking at the equation, what is the value of k? 4. Because plus 4, so the value of k is 4. What's the value of h? Negative 3. So the vertex is the point negative 3, 4. Questions on this here? Now, what's the axis of symmetry going to be? Well, x is equal to h. Yes, we said h was what? So the axis of symmetry is x is equal to negative 3. Questions on this so far? Now, I'm going to show you kind of how this works, especially with graphing. I'm not going to make you graph any of these, but I want to show you how this works. Because up to this point, really to be able to graph a quadratic, before this we needed 5 points. Because you need 2 points for a line, 5 points for a quadratic. Now, since it's in vertex form, we do get the vertex. So negative 3, 4. And this is our first point. That is the vertex. Now, the axis of symmetry, we also got it. Well, take 2. Is this line here. This line here is the axis of symmetry, and everything is going to mirror across it. Now, all I need to do is get 2 more points, and since they mirror, I will have the other points on either side. Now, we normally did this with a table, x comma y, and our middle point is going to be the point negative 3, 4. And we get this here. Now I'm going to start off with negative 2, and what I'm going to do is just plug it into the function. So negative 2 parentheses negative 2 plus 3 close parentheses squared plus 4. Now when I work this out to get the y value that corresponds to it, negative 2 plus 3 is 1. 1 squared, 1 times 1 is 1. Negative 2 times 1 is negative 2. And negative 2 plus 4 is 2. So what that tells us is that the next point on this parabola is the point negative 2, 2. So you're not going to have to graph it, but I want to just show you guys how this works.
So that's how you graph it.
So if we were going to graph it, we would do this here. Now, One thing that's very interesting is that if we pick the next point, this time to the left, which was our, not -3, it's -4. Because we know -3. -3 gave us the vertex. Now, if we look at this here, -4 plus 3 is -1 squared. Well, -1 squared is 1, which gives us -2 plus 4, which is, apparently it's going to scroll, 2. But if you notice, the y values for one point to the left and right of the vertex is the exact same. That's because of the properties of our axis of symmetry. It's going to mirror each other, which means I didn't actually have to plug -4 in. As soon as I knew what the value of -2 was, I know what the value for y at -4. So if I do the same thing with -1, -1 plus 3 is 2 squared. Well, 2 squared is 4. -2 times 4 is -8. And -8 plus 4 is -4. So we have -1, -4 down here. What would the value of y be when x is -5? Well, this value over here would indeed be -4, because it's going to have this mirror image. And that there would be our parabola, because it's going to have this reflection. The y values are going to mirror each other. Now, to kind of look at this here, -2 parentheses x plus 3 close parentheses squared plus 4 graph. So it does kind of look like the parabola we have. Ours is a little bit skinnier because the scale, I think, is a little off based off this here. But if we look at the table, second graph, now we said the vertex was the point -3, 4. We can see that here. And if we look at the y values, sure. I was wondering why that looked a little off. Okay, that looks a little more accurate. So at -3, 4, we have the vertex. And if we look at the y values going one step away from it, they're both 2. We go 2 steps away, they're both -4, like we found. Third step away, -14, -14, -28, -28, -46, -46. They mirror each other all the way down. So if I wanted to graph it, 5 points, the middle one's going to be the vertex, and I just need to find 2 to the left or 2 to the right of it. Because once I find those, I have the other 2, because it mirrors it. All right, let's look at the next one. And again, on these here, we're not graphing. We just want to find the vertex and axis of symmetry. Now for us here, the vertex is h comma k. And we're going off of our a times x minus h squared plus k. And in this problem here, what is the value of k? -2. And what is the value of h? -4. So the vertex is the point -4, -2. What would the axis of symmetry be? X is equal to -4. Because x is equal to h, our h value is -4. So it's saying the axis of symmetry is x is equal to -4. Questions on this here? Questions on any of this here so far? Let's look at the next one. F of x equals -3x plus 1 squared. We're not graphing. We just want to find the vertex and the axis of symmetry. So our vertex is h comma k. What's the value of h? -1. So the first value of the vertex is -1. Also tells us the axis of symmetry is x is equal to -1. What's the k value of the vertex? 0. And when you do label the axis of symmetry for these here, we need x equals -1. We can't just have -1. Because the axis of symmetry is an equation, not just a single number. Questions on any of this here so far? The graph g of x equals 2 times x minus 2 squared plus 5. First part we need is the vertex. And the other part we need is the axis of symmetry. So the vertex is our h comma k. What would our vertex be? Yes, 2, 5. Positive 2, positive 5. Because x minus 2, it would come out as positive 2. Plus 5 would come out as positive 5. Yes. What would the axis of symmetry be? Yes, technically it is x is equal to 2, but yes. Questions on this here? Questions on any of this so far? Yeah. Yeah, I do shorten that to A of S, axis of symmetry. And one thing I will say to be cautious of, you can do A of S, that's perfectly fine. Just do not put A of S is 2. Yes. Because you cannot say that the axis of symmetry for this is just 2. Because again, we'll look back at this here. Because the axis of symmetry, like on this one here, is not just the point 2, it is the entire equation going straight up and down. It's that whole equation. So we have to have the x equals. Because 2 is just a number, it's not signifying the entire line. Does that make sense? It's, I think the closest way we can relate it to is when we try to talk about the state of Oklahoma, but we only say Concord. It's not grasping everything that is a part of it. It's just that one spot is the closest I can get to it. It's not an exact connection, but it is as close as we can get. Concord. Quadratic functions can also be written in what we call standard form, ax squared plus bx plus c. Now this here is a written out step-by-step version of how we go from standard form or from vertex form to standard form and how the A, H, and K relate to A, B, and C. Now having a full understanding of this is not important. What is important is the key concept here. Now, the parabola, the value of A is still working the same as it did in vertex form. If A is negative, we have a negative in the A spot, it is a reflection across the x-axis, which means instead of opening up, it opens down. So that's not changed. If the value of A is greater than 1, it's a vertical stretch. If it's between 0 and 1, it's a vertical shrink. That's all these first two are talking about. Now the axis of symmetry in standard form is x is equal to negative b over 2a. And the vertex is negative b over 2a comma f of negative b over 2a. Now, one other interesting point is that the y-intercept is c, or the point 0, comma, c. And the y-intercept part is kind of interesting because if we look at this equation, ax squared plus bx plus c, the y-intercept is going to be the y value for when x is 0. The x-intercept is when y is 0. But if we look at this function, ax squared plus bx plus c, for any value of a, if I plug in 0 to this here, no matter what a, b, and c are, well, what is a times 0 squared? Well, what's 0 squared? A times 0 is, so that is gone. What's b times 0? So we're left with c. So whatever the constant term, the term without a variable is, in standard form will be the y-intercept. If there's not one listed, it means the y-intercept is the point 0, 0. Yes, and when we write it in standard form, and normally we'll write it with an x squared, we write it in descending order of power. So square is the biggest, x to the first is next, number without a variable is last. So that's kind of a side anecdote. Now, looking at the vertex and the axis of symmetry, I think it's going to be easier for us to see how this works by actually finding it than it is to look at just the formulas. Now, all this here in this equation is being related back to our ax squared plus bx plus c. Now, looking at this formula here, what is the value of a? A is the number in front of x squared. 3. You're good. So a is 3. What's the value of b? Yes, -6, because we take the negative with it.
Oh, so we take negative with it.
Because if we look at the general form, it's plus bx, so which means b has to be negative. And what's the value of c? 1. So a is 3, b is -6, and c is 1. Now, one of the main formulas that we have in both of these here is the negative b over 2a. So we need to find its value first. Negative b over 2a. Negative. What's the value of b? We said it was -6. So we replace b with its number for this equation here, -6. Over 2 times a, well, a in this case is 3. Simplify. Now at this point here, we could do this by hand. Well, the numerator, -6 is +6. 2 times 3 is 6 divided by 6 is. So what that tells me is that the vertex the x value, the negative b over 2a is 1. We can fill that in. The axis of symmetry was x is equal to negative b over 2a, so x is equal to 1. I plug the numbers into that one formula, and we have 2/3 of the answer we need. Yes, we have the entire axis of symmetry. We have half of the vertex. Questions on this here? Now, the next thing is figuring out what does it mean by f of negative b over 2a, yes? Well, we can start off with f, but I already know what negative b over 2a is. It is 1. So we're really saying And we want to find out what f of 1 is. Well, I replaced x with 1, which means every x in this function has to be replaced with 1. So what we're looking at is 3 times 1 squared minus 6 times 1 plus 1. Well, 1 squared is just 1. Negative 6 times 1 is negative 6 plus 1. 3 times 1 is 3. Negative 6 plus 1 is negative 5. And lastly, 3 minus 5 is negative 2. So the vertex is the point 1, negative 2. And the axis of symmetry is x is equal to 1. So really, all we had to do is find the x value of the vertex, plug it into the function to find its corresponding y value. That's all f of negative b over 2a is.
So that plus 1 is.
It does, it just doesn't connect to the axis of symmetry or the vertex. Because if we graphed it, 3x squared minus 6x plus 1 graphed, we have this here. Second table. So as we can see here, 1, negative 2 is the vertex. And all the y values going left and right from it do mirror each other. Incidentally, when x is 0, the y value is 1. It's our y-intercept, is what it tells us. Now, it will come into play in other parts when we start solving quadratics. We'll need that value to plug in, but at this point, we don't need it for that. Questions on vertex or axis of symmetry? Let's look at the next one. And as we found on the last one, really the only thing we need to solve for first is negative b over 2a. Yes? So let's solve for it first. Negative b over 2a. So, and again, this is relating back to ax squared plus bx plus c. So what's the value of b?
Or
2. It's just positive 2. Because we don't have parentheses, so we don't have to worry about changing signs. It's just positive 2. What's the value of a?
1.
It's 1. Since a number is not written in front of x squared, it's understood to be 1.
So is there always going to be an x squared there?
Yes. And the reason for that is according to kind of higher degree polynomial functions, the x squared is what we call the quadratic term. So the x squared is the quadratic part. The x is what we call the linear term, because if it was just ax plus c, it's just the equation of a line. And c is our constant. It's just a number. So if a was ever 0, it would not be a quadratic anymore. It would just be a linear function. So we will always have an a value. Now we need to evaluate this here, yes? I mean, we don't have to do it by hand. We can do it in the calculator and let it tell us that it is -1. So the x value of the vertex is -1. The axis of symmetry is x is equal to -1. Now the other half of this is to find f of -1. F of our negative b over 2a, but we know negative b over 2a is -1. So we'll have -1 squared plus 2 times -1 minus 1. Well, squared plus 2 times -1, was it 1 plus 1, was it? And we get -2. Which means the y value of our vertex is -2. Questions on axis of symmetry or vertex? I feel good with these here. Let's look at the next one. Now to find the vertex or the axis of symmetry, the first thing we need to find is our negative b over 2a. Well, looking at this equation here, what is our value of b? -8, because we're going off our ax squared plus bx plus c. So we'll replace b with -8. And the value of a is? Yes, sir.
I'm sorry.
No.
Will you tell us off if on the test or on the homework if we just like skip putting into that and just put 8?
As in the h value or the x value of the vertex?
Well, like.
Oh, I see what you're saying.
Yeah. So we just put like solve it like that, put 8. And
Yeah.
-2, or 4, -1. Put it like that and then solve all that.
Yes. Because you're doing the steps, you're just not doing them individually. Yeah. I mean, if you wanted to, we could have just gone straight to the calculator and said negative, or just 8 over 2 times -2. Now the next part is what? To find the y value of the vertex, yes? So we're going to plug -2 into our equation and simplify. Now I'm going to do this one by hand. We could plug it into the calculator because -2 squared is 4. -8 times -2 is plus 16 plus 1. -2 times 4 is -8. 16 plus 1 is 17. And -8 plus 17 is 9. So the vertex is the point -2, 9. Well, I missed one part. Axis of symmetry is x equals -2. Questions on any of this here? Questions on anything we've done so far? Because once we get an understanding of how to plug it in, it's really just plug it into the equation, simplify. And we'll start with this here, maximum, minimum values tomorrow.